In the 1770s, there was a factory that ran almost entirely by itself. No electricity, no steam engines, no motors. And yet, machines moved, threads spun, and production continued with barely any human hands touching the work. While most of the world still relied on manual labor for everything, this place had figured out something that shouldn't have been possible yet. It was a building where mechanisms controlled other mechanisms, where one source of power branched into dozens of automated processes, where the factory essentially managed itself. The man who built it wasn't trying to create the future. He was just trying to solve a very specific problem in the present. But what he ended up creating was automation before the word even existed. This is the story of Richard Arkwright's water-powered mill in Cromford, England, the factory that ran itself before electricity even existed. Richard Arkwright wasn't an engineer. He was a barber and a wig maker who saw an opportunity in the cotton industry. His problem was simple. Spinning thread by hand was slow, inconsistent, and required an army of workers. He needed a way to produce more faster, with fewer people. His solution was mechanical intelligence. Not computers, not electronics, but an intricate system of gears, shafts, belts, and levers that could make decisions without anyone telling them what to do. Here's how it worked. A single water wheel outside the building turned one massive axle that ran the entire length of the factory. From that one rotating shaft, power was distributed through a network of smaller shafts, pulleys, and gears to hundreds of individual spinning machines. But the brilliance wasn't just in powering the machines. It was in how they were synchronized. The gear ratios were calculated so precisely that every spinning frame moved at exactly the right speed relative to every other machine. The thread was pulled, twisted, and wound automatically, with no human adjustment needed. Arkwright essentially built a mechanical brain. Each gear was a tiny decision-maker. If one part moved, it triggered another, which triggered another, creating a cascade of automated actions. He was solving annoying little problems, figuring out how to keep tension consistent, how to stop thread from breaking, how to restart a process without manual intervention. And in doing so, he accidentally laid the foundation for modern automation. Let's walk through what actually happened inside this factory, step by step, because this is where it gets wild. Water from the nearby river hit the wheel. The wheel turned the main shaft. That shaft ran through the entire building, spinning constantly. Branching off from it were dozens of secondary shafts, each one connected by leather belts and wooden gears. These secondary shafts powered the spinning frames. Each frame had multiple spindles, and each spindle twisted raw cotton into thread. But here's the key. The machines didn't just spin, they sensed. If a thread broke, a mechanical clutch would disengage that specific spindle, stopping it without stopping the entire machine. No alarms, no sensors, just physics. A loss of tension meant a loss of friction, which meant the mechanism released. Purely mechanical feedback. The machines also regulated their own speed. If the water flow increased, the entire system sped up proportionally. If it decreased, everything slowed together. The factory breathed with the river. There were no electric timers, but there were mechanical ones. Weighted levers and escapement mechanisms controlled cycles, making sure each stage of production happened in the right sequence. Machines essentially kept time for themselves. And perhaps most impressively, the factory had built-in safety systems. If a shaft started spinning too fast, centrifugal governors would kick in, physical weights that swung outward and triggered brakes. No electricity, no computers, just elegant, self-regulating mechanics. This was modern automation, 150 years too early. The consequences of Arkwright's system were massive, and most people at the time didn't even fully understand what they were witnessing. First, labor. Traditional spinning required one person per spinning wheel, working all day to produce a small amount of thread. Arkwright's mill could do the work of hundreds of spinners with just a handful of supervisors. The machines did the work. The people just watched. Second, consistency. Human workers get tired, make mistakes, work at different speeds. Machines don't. Every thread came out the same thickness, the same strength, the same quality. For the first time, industrial production was predictable. Third, scalability. Once Arkwright proved the system worked, he built more mills. Then others copied him. Within decades, water-powered factories were everywhere, transforming entire regions of England into industrial centres. But there was a darker side. The debate over automation versus labour didn't start with robots or computers. It started here. Workers saw these machines as threats. Some were right to worry. The skills they'd spent years mastering were suddenly obsolete. Factory owners, on the other hand, saw only efficiency. Why pay dozens of workers when a single machine could do more, faster and cheaper? Arkwright became enormously wealthy. The workers did not. Many people at the time thought it was just another factory, just another way to spin thread. They didn't realize they were watching the birth of something much bigger. A system where machines managed production, where human labor became optional, where the logic of automation began to take hold. It was a turning point, and most people missed it. Ask someone to name the most important invention of the Industrial Revolution, and they'll probably say the steam engine. Maybe the power loom. Almost no one mentions Arkwright's water frame. And yet, this forgotten innovation set the template for everything that came after. The idea that a single power source could drive an entire interconnected system. The idea that machines could regulate themselves without constant human oversight. The idea that production could be automated, standardized, and scaled. Today, Arkwright's mill in Cromford still stands, but most of the mechanisms are silent. The wooden gears have worn down, the leather belts have rotted away, the water wheel no longer turns. It's a museum now, a relic of a time when people built the future out of wood and iron and river water. But walk through those rooms and you can still see it. The layout of the machines, the positioning of the shafts, the logic of how everything connected. It's all still there, frozen in place, waiting for someone to understand what they're looking at. Because here's the thing. When you look at a modern automated factory, with its robotic arms and computer controls and sensor networks, you're looking at the same fundamental idea. A central system distributing power and instructions to individual machines. Feedback loops that detect problems and correct them automatically. Processes that run without human intervention. The technology has changed. The principle hasn't. Richard Arkwright didn't invent automation, but he proved it was possible. He showed that machines could think in their own mechanical way, that factories could run themselves. And we've been chasing that vision ever since.